Hey, hello geometry students. Welcome to our 7.3 on similar triangles. And so we're going to be taking what we've been looking at in terms of similarity, ratios, and proportions, and also similar polygons, and looking specifically at triangles. You know, we've already done congruent triangles, and if you remember, that is when we were looking at various theorems that would prove triangles congruent, like side, 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 sine to angle side, angle side, etc. This is going to be similar, though I think a whole lot simpler, a little more and briefer too. So first off, congratulations. There's no definitions. There's nothing we need to define. I might just briefly remind you of what similar means. Similar means same, two shapes that are or things, but two shapes in this case, or two triangles that are the same shape but different sizes. And so we're going to look at a couple of theorems as to for how to prove or know whether or not triangles are in fact similar. Again, with the same shape, but even though they're different sizes. And so we're not going to need any definitions. We just have two questions. That's it. So the first question is, what are three ways that you can know triangles are similar? So let's break those down. The first one, and this is going to, again, kind of harken back to triangle congruency, as you'll see. The first way is it's called AA. Okay, standing for angle, angle. If you know that two angles within triangles, go and get some triangles up here, and we'll call this A, B, C, and D, E, F. Okay, if I know that two angles within these, so let's say B and E are congruent, and D and A are congruent. If I know that two triangles are congruent, or two angles within two triangles are congruent, then those two triangles have to be similar. Because one, you know the third angle is assumed because there's only 180 degrees. And so if you have two congruent angles, the third one has to be included. And as we said, the definition of similarity is same shape. And what determines the shape of a triangle or other polygon are its angles. And so if you've got all congruent angles, then you've got two similar shapes. So making that as simple as possible, you just need to know the two angles. And so because of the two angles, we can know that triangle ABC is similar to triangle DEF. Okay, so if you have two angles, you're in business. What's the second method? Second method is side, side, side. We'll just change up the color. Side, side, side. And so this gets us into some triangles. And we'll go ahead and do it the way the book does it. Some color to represent what we're talking about. Okay, and so say I have triangle, we'll go ahead and call this GHI and JKL. And the reason I drew at the sides in various colors basically represent that GH is proportional to JK, and GI in the red is proportional to JL, and HI is proportional to KL. Then we can know. So in other words, if all three sides are proportional, then we can know that the triangles are in fact congruent. The way that you would note this is basically that HG, let's undo it this way, if HG were divided by JK, that would give us that similarity ratio. That would have to be equal to, if I were to divide HI by KL, and if that were also equal to GI divided by JL. If that division gives you the same ratio, that's how you would know all three sides are proportional. And you do need to know all three sides in this case, but that then is enough to know for sure that those two shapes are congruent. That's basically nothing new. That could be assumed based on what we talked about in 7.2. But so that's side, side, side. Then the third method is side, angle, side. And so that's kind of a combination of these first two. And that's basically saying that if you have just two of the sides, okay, and then an unknown third side, but then you know the angle in between them. So if I know, let's go ahead and call this, let's see, RST and UVW. Okay, if I know that RS is proportional, notice we're not saying equal. I'm not putting any congruent signs on this. This is if they are proportional. In fact, I'm going to note that right here. Proportional, not congruent. But if we'll just go ahead and write it just like we did before, if SR divided by VU is equal to ST divided by VW, and you've got the fact that, put it in blue, angle S is congruent to angle V, then those two triangles are also, oh, you can't see that, but I'll scroll up. Then those two triangles are also proportional. So you've got three ways. Either you can know two of the angles, you can know proportional all three sides, or you can know two sides proportional and the angle in between them. So AA, side, 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 and side, angle, side. Okay? And the way you prove proportionality is to divide and see if they have the same similarity ratio. Okay, let's try out on one problem from the book. This is page 474. We're going to do number 6. And here you need to basically explain why. I've got two triangles here, and I have to explain why is like UVW proportional to XWY. And so let's take a look. And then we have to find, for number 6, we have to find WY. So I'm going to need to find this length right here. Okay, so we're going to practice solving proportions. So let's see, what do we know? Well, I can see that, and again, you want to be, one of the tricky things is to make sure you understand which sides are related to each other. So we have here, this side, VW is proportion or corresponds to XW. So I need to find out, well, oops, that's getting a little bit off on a tangent. Let's look at what we know is congruent with these two triangles. So first of all, I have vertical angles. And so I can see that this angle and this angle must be congruent. So these two triangles share a congruent angle. So now it doesn't look like I'm going to prove this with side, 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 because I don't know hardly any of the sides. I only know 3. I need to know, 3 more. And they give us these symbols here that X, Y, and UV are parallel. So that means whenever you see parallel lines, what do you want to think of? You want to think transversal. So you basically have a transversal right here, okay, with two parallel lines and VX cutting across as your transversal. So that means you have alternate interior angles. In other words, V is an alternate interior angle with X. And so those also must be congruent to each other. And so if we go back and check, that's so easy you might forget. But if I know that two angles, going back to AA, if two angles are congruent to each other, then that's enough information to know that these triangles are similar, not congruent, but similar. So because, let's go ahead and note that, angle UWV is congruent to angle YWX, and angle V is congruent to angle X, then I know they are similar. Let's go ahead and name the triangle UVW is similar to triangle YWX by AA. Okay, because I was able to show that two of the angles are congruent. I could, in fact, because it still applies, you still have a transversal here. I could prove U and Y are congruent too, but that's already given. It's the third angle, and you don't need 3 angles. You only need the first 2. So that's the first part of the question. I know these are similar because I have 2 congruent angles. And so for problems like this, you're choosing from one of these 3 methods: angle, angle, side, 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 or side, angle, side. In this case, it's AA. So then the last part of the question was, we need to prove, or not prove, we need to find since they are proportional, I should be able to find WY. And the way you're going to do that is by setting up a proportion. In other words, as I started to say, I know that this side and this side, here and here, they correspond to each other. So I know that 7 to 8.75 has to be equal to, and have the same similarity ratio basically, as 9 to WY, which I could just call X, but because X is up there, I'm going to call it WY. So if you see that, I have this side is to this side, as this side must be to that side. Notice it's important to see if you were to lay the triangles on top of each other, that V corresponds to X, U corresponds to Y, and of course the W's correspond to each other, so that you set up your proportion correctly. So that's always, in solving proportions, always take a moment to pause and make sure you've set this part up right. So 7 corresponds to 8.75 and 9 corresponds to WY, the side I'm trying to find. So now we just need to solve the proportion. And that's something you want to get very good at in this chapter because proportions are very handy and really not that difficult to solve. But we're just going to find our cross products. So we're going to just simply do 9 times 8.75 equals 7 WY. All right, and then we're going to solve it by simply dividing by 7. So there's our pattern: cross multiply and then divide. Cross multiply the two numbers that are parent and then divide by the third number. You'll get very good at this. So 9 times 8.75 divided by 7, and what you get from that is 11.25. Okay, so WY is 11. Can't see it. WY is 11.25 because I cross multiplied and then divided. And again, if I took 7 and divided by 8.75 on your calculator and I do 9 divided by 11.25, that you'll get the exact same number, the same similarity ratio. Okay, so 2 skills being used here. Identifying one of the 3 ways of proving triangles similar, and then setting up a proportion and solving that proportion. Probably our number 1 skill you want to have coming out of all chapter 7 is just being able to set up a proportion and solve it confidently. All right, we'll see you in class. We'll address any questions, and we will, as always, have a great time. All right, see you soon.